Welcome to another video, the same every time, GCSE Maths. We're looking at differentiation and stationary points. And straight into this one, a curve has equation y equals x cubed minus 3x plus 4. Work out the coordinates of the two stationary points. So, as I said in the previous video, this does look like a fairly high-end topic, and I can understand why some people might pass by this question and do something else. It is worth a lot of marks, it's a 5-mark question, and they don't really guide you through it. But the theme of these videos is the same every time. It is the same every time. As long as you do the same thing, you can learn how to do it, and you can follow the same method. So the coordinates of the two stationary points, if you see these words, stationary points, or you see the words turning points, it means the same thing. First of all, we have to differentiate. So write down dy by dx, differentiate, multiply by the power, and then take away 1 from the power. If you have just a number times by x, the differentiation is just the number. And if you have a number on its own, then the differentiation is 0. So that one is minus 3, and the plus 4 will differentiate to 0. So stationary points, the differentiation will be equal to 0. So at the stationary points, sometimes called turning points, the dy by dx equals 0. So your first move to get yourself into the method marks, work out the dy by dx, differentiate, and then put your differentiation equal to 0. So this equation we can solve, I think, just by going like this, can't we? 3x squared equals 3. So dividing by 3, x squared equals 3 divided by 3. So x squared equals 1. So x is going to be square root of 1, but be a little bit careful because we need, for these questions, plus or minus square root of 1. So x could be 1 or negative 1. X squared equals 1. 1 squared, 1 times 1 is 1. Negative 1 squared, negative 1 times negative 1 is also positive 1. So we are already well into the marks here. Work out the dy by dx, put the dy by dx equals to 0, solve for x, and we can see from this question, the way they've written the answers, that we are expecting 2 possible solutions. Now they say in the question that they want coordinates of the stationary points, and coordinates means x and y. So to find the y values, what we need to do is to go back to the original equation, the equation that they give us first in the question. This will give us the y values. So when x equals 1, I just put 1 instead of x. So 1 cubed minus 3 times 1 plus 4. Probably we can do this non-calculator. 1 cubed, 1 times 1 times 1. Minus 3 times 1 plus 4. So 1 minus 3 would be negative 2. And then plus the 4 would give us positive 2. And then we need to do that again for x equals negative 1. Remember, these have to go in pairs. The 1 for the x belongs with the 2 for the y. And when x is negative 1, putting that into our equation, a little bit more complicated this time. I'm using brackets here because I'm using a negative number to a power. So negative 1 cubed minus 3 times negative 1 plus 4. Again, we can maybe do this non-calculator. Negative 1 cubed is negative 1 times negative 1 times negative 1, which is negative 1. And 3 times negative 1 is negative 3, so minus negative 3, then plus a 4. So that's going to be negative 1, minus minus 3, so plus 3, plus 4. Negative 1 plus 3, that gives us 2, and then plus 4 gives us 6. So the y equals 6 belongs with the x equals negative 1. So there we are. We have our two coordinates, our two sets of coordinates for our two stationary points, 1, 2, and negative 1, 6. And in part B, we are again on familiar ground, as I keep saying, the same every time. So you need to know what we have to do here. Determine whether each stationary point is a maximum or minimum. Give reasons for your answers. It's literally the same question that we saw on the previous video, except of course the numbers are different. So what we need to do when we are determining if it is a maximum or a minimum, we need the second differential. So let's do the first differential again. 3x squared minus 3 was the first differential. And the second differential, d2y by dx, 2. Differentiating again, 2 times 3 would be 6, x to the power 1. Then just the 3 on its own, the minus 3 on its own, will differentiate to 0. So 6x. And all we have to do here is work out what's going on at our two stationary points. So when x was negative 1, 6x, 6 times negative 1 is negative 6. Well, that's less than 0. Negative 6 is less than 0. So that tells us there is a maximum at x equals negative 1. And the other possibility was x equals positive 1. So 6 times positive 1, putting the x value into the second differential, the second differentiation. 6 times positive 1 is 6, and as we know, that's greater than 0. So if your second differentiation is greater than 0, you get a minimum. So minimum at x equals positive 1. So that's the end of that question. The same every time apart from the numbers. You can learn how to do it. Of course, they don't give you a lot to work with on this. They're not taking you through the question step by step, but that's what I'm doing here. And I hope that was useful to you. And I hope that you do see a question like this on your exam, because you're going to know exactly what to do. If the video was useful, then please do like and subscribe. That's useful to us. Thank you very much for watching. I will be back for the next video.